Hi, this is Dr. Kiranmayee, professor in the Department of Computer Science and also in charge for the technical trainings at VNR VJEC. So today I'm going to discuss about one of the application of the stack, that is Infix to Postfix conversion using stack. So when we want to convert the infix expression to the postfix expression using stack, so first we would like to know what do you mean by an arithmetic expression. An arithmetic expression is an expression which is a combination of left parenthesis, right parenthesis, operands. Operands means it can be the variables like A, B, C, D, and also operators, arithmetic operators like plus, minus, star, division, and some cases we use also power. So a combination of all these put together is called as an arithmetic expression. Now this arithmetic expression can be written in the form of a notation. So the way you write the arithmetic expression is known as the notation. So there are three types of notations for an arithmetic expression. So those are infix notation, prefix notation. Prefix notation is also called as the Polish notation. Next, postfix notation. This is also called as the reverse Polish notation. So what is an infix notation? Infix notation, always the operator exists between the operands, two operands. So here A and B are the operands, and here in between it is an operator. So the expression or the notation of this particular form is said to be an infix notation. Next we have a prefix notation. Prefix notation is here operator followed by the operands. So if A and B are the operands and this is one of the arithmetic operator, so operator followed by the operands, this notation is called as the prefix notation. Next we have the postfix notation. Postfix notation, first the operands followed by the any of the arithmetic operator. If any arithmetic operation expression is of this particular form, then we say it is a postfix notation. So in case of an infix notation, always existing of the parentheses will be there. Suppose A into B plus C minus D by E is an arithmetic expression and also comes under the infix notation. So this infix notation will not be understandable by our system. So only the system can understand the parenthesis free notation. That is, it can understand the prefix and also understand the postfix notation. So that is the main reason why we want to convert the infix expression to a postfix expression. So you can also convert this expression manually. Okay, so manually if you convert it takes more time and it is not reasonable. So we want to automate this particular process using stack. So stack plays one of the important role, and also one of the major application of the stack is converting the infix expression to postfix expression. So now suppose these are all the examples of the infix notation. And we have seen this one, this is infix. Then operator followed by the operand is a prefix notation. Then operands followed by the operator is a postfix. Now suppose A plus B into C. See, now the parentheses are existing only in the case of the infix notation. So manually, suppose if you want to convert this particular expression into postfix. So first within the parentheses whatever it is there, we convert. So A, B plus. Now this is considered as one operand, suppose A, then we say star C. So again this is one of the operand and this is another operand. So operand star operand. So here again postfix. So what you're going to do, AB plus operand 1, operand 2 followed by the operator. So see, AB plus C star is the answer for the postfix. Similarly, prefix, if you want to convert, same expression AB plus into C. So what we do is, here A plus B, you can convert as prefix, means plus AB into C. So this is one operand, this is another operand. So operators followed by the operands is the prefix notation. So here what we do, this consider as C. So operand, so star we say, then A plus B, plus B, this is wrong. So what we do is star plus A, B, C. So this is the prefix notation. So operand 1, right, and operand 2, operator. So operator followed by operand 1 and operand 2. This is the answer for the second one. So similarly, the remaining 3 also, the remaining 3 to 4, these are the examples. You can solve it manually. If you want to solve it manually, this is the procedure. So but here you practice it manually and check whether you are going to get these particular answers or not. So manually doing, it's very difficult for us and we don't know whether it is the correct answer or not. So what we do, we use tag for converting the infix expression to the postfix expression. So we see an example, one of the example we will see and we will convert using the stack. So before going to the example, what is the need for converting this infix expression to the postfix expression? So the one of the main reason is parenthesis free expression. So in the postfix expression, there will be no parentheses. If there are no parentheses, then there is no ambiguity in which one has to be solved first. Then removes precedence rules here. If in case of an infix expression, okay, we need to follow compulsory to the precedence of the operators in order to evaluate or else in order to convert the expression. But if you are removing these particular precedent rules are not there, then easy for us to evaluate the postfix expression. So now makes the evaluation easy. So why we are converting the infix to postfix expression is we can evaluate that particular expression. So evaluation means what? Suppose you consider AB plus is a postfix expression. So I want to evaluate it. Evaluation means what is the value of that particular expression. Suppose A is equal to 5 and B is equal to 3. So here 5 and 3 plus. So here the answer is 8. So this is the value of this particular expression. So makes the evaluation easy using stack. If we use the stack, evaluation is easy. Then improves the execution speed. This is quite natural because there are no parentheses in the postfix expression and also you're removing the precedence rule. So naturally the execution speed will be improved a lot. And one of the other need is it is useful in the compiler design. So in designing the compiler, it is plays an important role. That is when you are defining the language syntax, parsing and generating the intermediate code. In these cases, we are going to use the postfix expression. So now we see this is the example given. I want to convert this expression using stack. So now we will step by step, we are going to convert the expression. So the first one, this is the expression. So the first step is, first move the left parenthesis to the stack and add a right parenthesis at the end of the expression. This is the first step. Add the left parenthesis to the stack and add the right parenthesis to the end of the expression. Now scan symbol by symbol. The first is nothing but an operand. If an operand is scanned or encountered, add it to the postfix expression, right? If at all an operator is encountered, you have to add it to the stack. So at any point of time in the stack, if you observe, you have only the left parenthesis and also the operators, right? So if an operator is encountered, then you have to place it in the stack. So far you have a left parenthesis and on the top of the stack you have a plus. Next symbol encountered will be the left parenthesis. So left parenthesis, if it is scanned, so you have to add it to the stack. Now so far the postfix expression is A and this is the content of the stack. Next is the symbol scanned will be B. So if an operand is encountered, add it to the expression. Next is operator. Operator is encountered, add it to the top of the stack. So multiplication. Now next is C, an operand. Operand is encountered, means add it to the postfix expression. Next, see here, on the top of the stack, you have already the multiplication, right? On the top of the stack, you have a multiplication symbol. And the symbol scanned is minus. Okay, so whenever a higher priority is on the top of the stack, you cannot place a lower priority operator, or else equal priority also. Suppose plus is there, the minus also you cannot keep it on the top of it. So whenever equal priority operators are there and also the highest is on the top of the stack and the minus, that is the lower priority, is to be scanned, has to go onto the stack. What we do is you pop it from the stack and add it to the expression. Now then your minus will be added to the stack, right? So a care has to be taken now. When has the operator to be popped means whenever highest priority or the equal priority operator is on the top of the stack, then remove that, that is pop from the stack, add it to the expression. Then you need to push that particular operator onto the top of the stack. So that's where we got A, B, C star. Next symbol is left parenthesis. So whenever a left parenthesis is encountered, push it onto the stack. Now next is D. Okay, so D, it is an operand, so add it to the expression. Next we have an operator. Operator on the top of the stack, you have to push it onto the top of the stack. So on the top of the stack you have a division. Before that you have a left parenthesis, so no comparison of the operators. Next operand, add it to the stack. Next power, add it, because here now the division is the lower priority. So on the lower priority you can place a higher priority operator. So push onto the stack. Next the symbol scanned will be F. So F, add it to the expression. Now right parenthesis. So when the right parenthesis is encountered, you have to remove all the particular operators from the stack and add it to the expression till the left parenthesis is encountered. And after adding all the operators to the expression, left parenthesis is also will be removed. In that way, now the top of the stack you have power. So power is added. Then you have a division. So division is added. Then left parenthesis is there. So remove the left parenthesis and don't add it anywhere. Remove from the stack. So that's way you have, now the current content of the stack is left parenthesis plus left parenthesis and minus. Now when the multiplication operator is encountered, add it. So on the lower priority you can place a higher priority operator. Next G, operand is encountered, add it to the expression. Like again right parenthesis is encountered. So when the right parenthesis is encountered, remove from the stack all the operators until the left parenthesis is encountered. So that's where star is added over here, then minus will be added over here, and remove the left parenthesis and don't add it anywhere. Remove from the stack. Now the current content of the stack is left parenthesis and plus. Next symbol to be scanned is multiplication. So multiplication is an operator, you place it on the top of the stack. So on the lower you are placing a higher priority. Next you have H. So H is an operand, so add it to the expression. Now after that you have a right parenthesis which were added at the end of the expression. So whenever a right parenthesis is encountered, so what you have to do, you have to pop it from the stack and add it to the expression. So star is added, then plus is added, alone only left parenthesis. So right parenthesis encountered means you have to remove all the operators and add it to the expression and remove the left parenthesis also. Then at the end you are going to get here none of the particular content is available in the stack. That means the stack is empty. Whenever the stack is empty, it seems that here you have evaluated the postfix expression. So the input whatever you are given for this infix expression, so the output will be A, B, C star, D, E, F power division G into minus H star plus. So this is the postfix expression generated for the infix expression using the stack. So this is the one of the main application of the stack. So the same example procedure, we have written an algorithm. So the first step in the algorithm is here, consider X is an input. So X is what? Input means input is a infix expression. What is Y now? Y is the postfix expression. The first step is what? Push the left parenthesis onto the stack and add the right parenthesis at the end of the X. X means the infix expression. Now here whenever an operand is encountered, so what we done, whenever an operand is encountered, you have added to the postfix expression. If at all a left parenthesis is encountered, we have pushed onto the stack. If at all operator is encountered, so whenever an operator is encountered, you have to check the operator precedence which is on the top of the stack and also the operator to be scanned whether they have equal precedence or as a higher precedent. So whenever a higher precedent operator is on the top of the stack, what you have to do? You have to pop it from the stack and add it to the expression. Then you have to add the operator to be scanned onto the top of the stack. Okay. Otherwise, if at all you have a less priority operator on the top of the stack and a higher priority to be scanned, just add it to the stack. Okay. If at all a right parenthesis is encountered, so if a right parenthesis is encountered, repeatedly pop from the stack until the left parenthesis is encountered. Remove the left parenthesis and don't add it anywhere. Okay. Remove the left parenthesis from the stack. And if at all, this particular step from 3 to 6 will be repeated until your stack is empty. If at all your stack is empty, then you have a required postfix expression. So a care has to be taken that when the operands always see that your stack content will be only left parenthesis and the operators. And here the expression content, when you are going to add it to the expression, means only the operands followed by the operators, right? When you are going to pop it from the stack means whenever a right parenthesis is encountered, you have to pop it from the stack, add it to the expression. And whenever you have a higher or equal priority of operators, then also you remove from the stack and add it to the expression. So this is the way how the algorithm will be implemented to convert an infix expression to the postfix expression using stack. Now, these are all the examples. You can try it on your own. These are all the examples. You can try it to get the postfix expression. So these are all the postfix expression. Do it first using stack. After that, what we do is you check it whether your answer is correct or wrong using manual conversion. Then you will be knowing that whether the answer or whatever you get it using a stack and the conversion using manually has to be get the same answer. Then it is only correct. So practice all these examples so that you will be thorough in converting an infix expression to the postfix expression. So next we see, in the next video, we are going to see the evaluation of the postfix expression. We have seen only conversion now. The next step is, the next application of the stack is the evaluating the postfix expression. So we are going to see very soon the next video. Thank you everyone.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.